Consider the following context. A ball is launched from the ground directly upward. If we look at the ball's height above the ground and the time elapsed since the ball was launched, we might be interested in making statements like, the ball's height above the ground is about 26.85 feet, 0.5 seconds after it was launched. But at this point, you might be tired of hearing and reading phrases that long. Mathematicians also got tired of such long, wordy phrases, so they invented notation to help them represent relationships without needing to describe it in words each time they want to reference it. In this investigation, we will learn about function notation as a way of representing the value of one quantity in a relationship based on the value of the other quantity. As a brief example, let's look at how the ball's height above the ground in feet is related to the number of seconds since the ball was launched. We can give this relationship a name by choosing any letter that we want, such as G. So we'll let the letter G represent the relationship between the ball's height and the time since the ball was launched. Now we know that anytime we see the letter G, we are talking about this particular relationship. Now in this context, if we let T represent the number of seconds since the ball was launched, then we can use the notation G, left parenthesis, T, right parenthesis, which is pronounced as G of T. We can use this notation to represent the ball's height above the ground T seconds after it was launched. So T represents the number of seconds since the ball was launched. This G of T represents the ball's height above the ground in feet. Now, these four symbols it's a lot shorter than saying the ball's height above the ground in feet T seconds after the ball was launched. Now, a few specific examples of using this function notation might look like the following. So if 1.5 seconds have elapsed since the ball was launched, then we can use the notation G of 1.5 to represent the ball's height 1.5 seconds after it was launched. So the ball's height in feet 1.5 seconds after it was launched. Now these four symbols pack in a lot of information, but it's very short and brief, which makes our life a lot easier when we want to reference how two quantities are related. Now let's go back to the applet and use function notation in this context. So we can let's look at some numerical examples. So let's assume 0.44 seconds have elapsed since the ball was launched. Then G of 0.44 represents the ball's height above the ground in feet. It doesn't matter what the value of T is, G of T is always going to represent the ball's height above the ground in feet. In general, so if we have a variable, say h, that represents the ball's height above the ground in feet, then G of T and h are representing the same thing. So in this case, G of T is really just equal to h. So what are the benefits of using this notation? See if you can figure them out before we explain them as you start to work through the first few examples in this investigation.